Let's talk about the third unit. So we've kind of gone through the first two units. We're going to go to the third unit. Rate of change and slope. Okay? Again, they're kind of the same thing. Although when we get into rate of change, we're talking about the change in the dependent variable, or maybe whatever the y is, over the change in the independent variable, which is whatever the x is. All right? So when you get into these word problems right here, this is showing a table for the balance of a bank account, okay, on different days of the month. So this is clearly a high schooler, all right? So the first day he got $550. The sixth day they got $285. The 16th day, $210, and so forth. And so the question is, during what time interval is there the greatest increase or decrease? Okay, and what that means is the balance decrease at the greatest rate. Okay, does that make sense? So then I'm going to go ahead and say, okay, well, for day 1 to 6, my change in the balance, we can say, is 550 minus 285 over 1 minus 6. Sorry. 1 minus 6. So then we have 550 minus 285 is going to give me 265 over negative 5, which is going to give me 265 divided by 5, negative 53. So there was a decrease of $53. All right, so I want you guys to find the rate of change for this interval, for this interval, and for this interval. From day 6 to 16, what's the decrease? Negative 7.5. All right, what's the decrease from 16 to 22? And from 22 to 30? So we can see here that the greatest rate of decrease is from day 1 to 6. All right, so that's kind of rate of change. All right, we're just taking the rate of, or we're taking the difference in the dependent value over the rate in the independent value. Now, slope, again, the same thing. All right, the rise of a run is the change in y over the change in x. I talked a little bit about this when we were doing the table and the graphs. But if I'm looking at this right here, and again, you're going to have to find the slope of a line from a graph. All right, and so some of these graphs, you will have to find what I call clean points. Okay, and a clean point is a point that's at the intersection of a grid, like this. So if I'm looking for 2 clean points on this graph right here, I can see that maybe I have a clean point right here, and I have a clean point right there. So this is what I want to be careful of with you guys. You're going to get into this, and you maybe have already kind of been exposed to it, where it's like, well, down is negative, right is positive, left is negative, up is positive. If you get confused with these signs, okay, don't do that. Just go ahead and fill out your rise over your run. And in this case, your rise, well, to go from that point to that point, is 1. Your run, to go from this point to this point, is 3. And then you step back and you ask yourself a very difficult question. Does this line go up or down? And it goes down, so therefore it's negative. And that's it. Don't get caught into the trap of this whole up is positive, negative, that kind of stuff. Don't do it. Okay? Just do your rise over run and ask if it goes positive, negative. Huh? Like you read, left to right. Okay? So again, similar situation here. I'm going to look for 2 clean points. I'm gonna say I got a point right here, I got a point right there. It actually shows you these right here. All right, so my rise in this case is 1, 2. My run in this case is 1, 2, 3, 4, 5, and clearly the line goes down. All right, and that gives me the slope of this. Correct. Because the slope of the slope of the line is constant. So everywhere along that line, that slope is always negative 2 over 5. All right, so this is what gets everybody confused. Okay, let's talk first about the slope. So if I just look at these 2 points on this line, my rise is 1, 2, 3, 4, 5, 6. My run, no, I don't go anywhere. So it's 0. And because as a ratio, I cannot take something out of nothing, the slope of this is undefined. This is a vertical line. Contrary to that, over here on a horizontal line, my rise is nothing. My run, 1, 2, 3, 4, actually this is 2, 4, 6, 8, 10, 12. But in that case, the slope is still going to be 0. So if I have a vertical line, my slope is always undefined. If I have a horizontal line, my slope is always 0. Now there's one more piece to this that I want to make sure that you understand. Every single vertical line, the equation of it is x equals something. Every single horizontal line is y equals something. Okay? And that something is wherever it crosses the x-axis. In this case, it crosses the x-axis at 3. So the equation of this line is x equals 3, x equals 4, x equals 5, x equals 6. Contrary over here, anybody have an idea what this equation is right here? 0. Because if you look, it crosses at 0 on the y-axis. Okay, if I had, this is y equals 1, y equals 2, y equals 3, y equals negative 3. Okay, so wherever it crosses the y-axis on a horizontal line, that's the y equals something. All right, so what's the slope of this line? So the slope is undefined. What's the equation of this line? X equals 0. All right, the slope of this line is 0. What's the equation? Negative 4. Y equals negative 4. All right. So, positive slope, negative slope, 0 slope, undefined slope. All right, so I want you to find the slope of this line, and I will give you the 2 clean points. I want you to find the slope of this line right here, and that's actually not going to find the slope of this line. What's my rise here? Well, they're actually both of them are correct. Okay. Maybe you were thinking, well, this is another clean point right here, so my rise is 1, my run is 1. If you still came over here, you'd have 3 over 3, which would still give you the 1. Okay, because the line's positive, positive. All right. So that is